Jai Hind everyone. Today I am going to discuss the topic graph theory. This is the basic topic of the network analysis and synthesis. So these are the basic contents of the today's lecture. First of all, I will give the review of the graph, then how to draw the graph and what is subgraph and what are the different types of subgraphs, that is tree and quadtree, and how to draw the tree and quadtree from a particular subgraph, what are the properties of a tree, and then I will discuss the topics, the fundamental tie-set matrix and the fundamental cut-set matrix. Also I will give some examples on the fundamental tie-set matrix and the fundamental cut-set matrix. So let's start with the first topic, graph. What is a graph? Basically a graph is a collection of nodes and branches, right? Nodes are represented by a dot or a circle and branches are also called as the line segment. So a graph can be formed by connecting the nodes with the help of branches, right? For drawing a particular graph, first of all we have from any electric network, first of all we will mark the nodes, right, and then by joining these nodes we will draw the branches between the nodes, right, and all the passive elements in case of any this is a network that I have taken as an example. So for joining any passive element, right, we will represent it by a single line called branch, right. You can see in this electric network I have shown 1, 2, 3 and 4 nodes are there and total 6 branches are shown here. One is the voltage in series with the resistor, second branch is the second branch contains the capacitor, in the third branch there is a resistor, in the fourth branch this is the inductor, and in the fifth branch this resistor is in series with the inductor, and in the sixth branch there is a inductor. So how to decide how to decide the number of branches for any particular graph or any particular network, right? So all the passive elements are represented by a single branch. For example, if I am having this resistor, then I can represent it with this branch, right? This resistor is having 2 nodes, so these are the 2 nodes, node number 1 and 2, and I can represent it by a line segment which is called as the branch. Similarly, a single capacitor or a single inductor can be represented by a single branch. So as I said, all the passive elements will be represented by a single branch, and the 2 sources, that is voltage source and the current source, these are represented by their internal impedance, right, that is voltage source will be short circuited and current source as an open its simple internal impedance is an open source, right. So we can consider the voltage source in series within any impedance as a single branch like this. If I am having this voltage source in series with resistor or any element inductor or capacitor, then I can replace this with a single branch. Similarly, if there is any current, right, and it is having any resistor or inductor or capacitor in parallel, then I can represent it with a single branch here. And if an voltage source is not containing any inductor, resistor or capacitor in series with it, right, so we can consider the internal resistance of that voltage source, and that single voltage source is also represented by the single branch. Similarly, same is the case for the current source, that if it is not having any impedance in parallel with the current source, then we can consider it its internal impedance and we can replace it by a single branch, right. So I will make the graph for this particular network. So in this network we have 4 nodes and 6 branches. So you can see here, first of all I will write the number of nodes, node number 1, node number 2, Okay, this is node number 1, node number 3, and this is node number 4. Okay. So in between node number 1 and 2 we have a capacitor, so it can be represented by a single branch. Okay. Now between node number 2 and 3 we have a single resistor, so it can also be represented by a single branch. Now you can see between node number 3 and the node number 4 we have two elements in series, that is inductor and the resistor. So the combination of two elements can also be represented by a single branch, but the condition is that we have to consider only two nodes, right? If I consider another node over here in between these two elements, so there are total 3 nodes in between these two elements, right? Then in that case I will consider the two branches, one for this resistor and one for this inductor. But here in this case I am considering two nodes only, that is node number 3 and the node number 4 in between these two elements. So I will represent these two elements with a single branch. Okay. And now between 2 and 4 there is another element, that is inductor, so I can represent it again with a single branch. And between 1 and 4 you can see there is a voltage source in series with a resistor, so I will represent this again with a single branch. And between 1 and 3 I am having this inductor, so it is also represented by a single branch. Now you can see I have drawn the graph for a particular network. Now this graph can be oriented in terms of the arrows. These arrowheads are showing the direction of current flow in any particular branch. So if any graph is having the number of nodes and the direction of arrows, then it is called as the oriented graph. And if a graph does not, like this graph, it is not showing any arrows, that is it is not showing the direction of current flow, so this type of graph is called as undirected graph. And now I am showing the arrows, that is the direction of current flowing in a particular network, so this graph will be called as the oriented graph. So you can see between node number 1 and 2, that is branch 2 is represented here, and the direction of current is from node 1 towards the node 2. And between node number 2 and 3 the branch 3 is represented here, and the direction of current is from branch number node number 3 towards the node number 2. Now between node number 1 and 3 the branch is 6th branch, and the direction of current will be from node number 3 towards the node number 1. Similarly in node branch, this is 1, between 1 and 4 the branch is first, branch name is 1, and the direction of current will be from 4 towards the 1. And this is branch number 4 here, and the direction of current will be towards node number 4, and 5th branch is having the direction of current flowing from 4 towards the 3. So this graph is called as the oriented graph or directed graph. If any graph does not contain any direction, and so we can say it as a undirected graph or non-directed graph. So here this is, I have taken one network to draw its graph, right? So you can see here this network is having one voltage source, one current source, and 1, 2, 3, 4, 5 resistor, right? And it is shown here that 1, 2, 3, 4 nodes are taken. So first of all I will draw the number of nodes, 1, 2, 3, and this is 4th node, which is a ground node, right? Now you can see here between node number 1 and 2 there is one resistor, that is of 5 ohm. It can be represented by one branch. Okay, this is node number 1, this is node number 2, and this is node number 3 here, node number 4. Okay, now between 2 and 3 there is another element, resistor, called resistor. So again I am showing it with a single branch. Now between 1 and 4, okay, between 1 and 4 you can see I have drawn this resistor, right, as a single branch, and between 1 and 4 there is another voltage source, so I can represent it with another branch, right. Now between node 2 and 4 there is a resistor, so I am drawing another branch for this. And you can see here between node 3 and 4 we have one element and one current source. So you can see that current source is in parallel with this resistance, right? So I can draw a single branch for these two parallel connected terms, right? So between node number 3 and 4 I will draw a single branch for this 4 ampere current source and this 20 ohm resistor. Now between 1 and 3 there is a resistor of 30 ohm, so I will represent it with a single branch. Okay, so you can see here in this network no direction is shown, okay, for the current flow. So I can take it myself and I can give the number of branches, name of the branches myself. So I am giving it as name 1, 2, 3, 4, 5 and 6. So there are total 4 nodes in this graph and 6 branches, right? Let me write it. There are branches, number of branches in this graph is 6 and number of nodes in this graph is 4. So you can see that the number of nodes present in the given electric circuit will be same as the number of nodes in the graph that we have drawn here. Okay, so this is the conclusion, that number of nodes will always be equal to the number of nodes present in the network given. Okay, and the second point is that the number of branches which are present in the graph will be either less than or equal to the number of branches given in the network or the electric circuit, right? Why? Because I have told you na ki we can take this connection as a by a single branch. We can represent this connection, this parallel combination by a single branch. So you can see here in this circuit there are total 7 branches, 1, 2, 3, 4, 5, 6, 7. But in the graph that I have drawn here, it is having 6 branches. So number of branches will be either will be equal or it could be less than the number of branches from the given network. But the number of nodes will always be equal in both the network as well as in the graph. We can also confirm this from this diagram and this graph which is given here. You can see here there are total number 4 nodes, right? Similarly here 1, 2, 3, 4 nodes are there and there are total 6 branches in this case, and we have 6 branches here in this graph. So here you can see the number of branches are equal in the network as well as in the graph. But in the next case that I have discussed, here the number of branches is not equal, that is it is less than the number of branches in the network, right? Now what is subgraph? See, actually a part of the graph is called as the subgraph. So basically subgraph is obtained if you remove any branch or node from a given graph. So basically the two types, it is of basically 2 types, tree and co-tree, right? So the number of branches in and nodes in a subgraph will be less than the original network, right, or original graph. So let's discuss this tree and co-tree one by one. These are the main topics, tree and tree, which will help us to design the cutset matrix and the tie-set matrix. So tree, what is a tree? A tree is a connection of subgraph, a tree is a connected subgraph of a given graph, and tree will contain all the nodes of the graph, right, but there should not be any closed loop in the tree, right. So this is the main property of a tree that we should keep in mind, that there should not be any closed loop while we are taking a tree, right, and the branches of the tree will be called as the twig. So you can see here I have taken this graph, and from this graph I can draw the tree. So first condition is that all the nodes will be included in a tree and there should not be any closed loop, right. So there are 1, 2, 3, 4 nodes, right, 1, 2, 3 and 4 nodes are there. Now I can draw the tree from these nodes, right. I have selected this as a tree. So you can see my both the conditions are satisfied here. It contains all the nodes and there is not closed loop, right. And from a particular given graph there could be many trees, right. I can draw this tree, मैं ये वाला tree भी select कर सकती हूँ, you can see, है ना, इसमें भी all the nodes are included and there is no closed loop, right. and I can also select this one. It is also included all the nodes and there is no closed loop, right. I can also select this tree. I can also select this tree. You can see again here 1, 2, 3, 4 all the nodes are included and it is not a closed loop. Similarly, I can also take this tree. So from a given graph I am drawing number of trees. So there could be number of trees from a particular graph. Any tree also. I can also take this tree. All the nodes are included here. All the 4 nodes are also included here and this is again not forming any closed loop. Similarly, I can also take, sorry, this will not be a tree because this is not a graph. There is no, this is not a node. Okay, similarly, number of trees can be formed from a particular graph. You can see, right. So what is the conclusion? That the number of branches of a tree should always be equal to n minus 1. आप देख सकते हैं, I have drawn 1, 2, 3, 4, 5 graphs from this, 5 trees from this graph, and in all the graphs we have same, in all the trees we have same nodes, that is 4 nodes, but the number of branches in all the tree you can see it is n minus 1, that is in these tree there must be 3 branches. So you can see here branch number 1, 2, 3, let me represent it by this B, C and this is D, right, 1, 2, 3. Here again this is D, E and F. There again 3 branches, यहाँ पे 1, 2, 3 branches, 1, 2, 3. In all the cases we have 3 branches. So the number of branches, that is called twigs. Okay, branches of a tree are called twigs. The twigs will be equal to n minus 1, where n is the number of nodes of any given graph. Now this is the example I have taken to draw the tree from this network. So from any electric network, if we want to draw any tree, so first of all we'll draw the graph, then we'll draw the tree from that particular graph. We cannot draw a tree directly from any electric network. Okay. So for this network there are 1, 2, 3, I'll select 3 nodes, node number A, this is node number B and this is node number C. Okay. So between A and C you can see that the voltage source is connected in series with the resistor. So between node A and C I can connect a single branch. Okay. So which is named as 1. Okay. And since no direction is given, I will assume myself the direction of this current. Now between node number A and C there is a single inductor. So again one branch can be formed between A and C, a single inductor, branch number 2, and I have given the direction, it is downwards. Now between node number A and B there is a resistor. So I will represent it with a single branch and will be giving it name as 3. Now you can see between node number B and C again there are 2 branches. One is a resistor, one is having a resistor, another one is having a current source, right. So I will represent these 2 different branches with a single branch. Okay. And I will give the direction and I will give the name it as branch number 4, and between A and between this you can see that this node and this node both are the same node, right. This is also a B node, right. So in between A and B there is one capacitor connected. So between A and B I will represent it with a single branch. Okay. And I will give it name as 5th branch. Okay. So you can see here I have drawn a graph for this electric network. Now from this graph I will draw the tree. So a tree must contain all the nodes, right? So A, B, C will be the 3 nodes, okay, in all the cases, okay, and there must not be any closed loop. So I can select branch number 1 and branch number 3 as a part of the graph, and this will be called as a tree, okay, and this branch 1 and 3 will be called as twig, right, because branch of a tree are called as twig. Again I can take these 3 nodes A, B and C, and now I will select branch number 3 and 4, okay. So these are the 2 connected branches which will again forming a tree, right, and another I can select branch number 3 and 2, it is carrying again all the nodes 3 and 2, and this is one of the tree, and I can also select branch number 5 and branch number 4. So it is also one of the tree from this graph, it is also containing all the 3 nodes, and branch number 5 and 1 भी consider किया जा सकता है, right, for a tree. And what else? This is 1 and 3, this is 3 and 4, okay, 5 and 1, 5 and 4, okay, 5 and 1, 5 and 4 भी हो गया, 1 and 3 भी हो गया, 3 and 4 हुआ है, हो गया. So these are the graphs from this, these are the trees from this graph. So also there is one formula for determining, ऐसे तो ना how you come to know कि how many trees will be formed from a particular graph. So there is formula for that. Number of possible trees will be equal to the determinant of A into A transpose, okay. So this A is called as the incidence matrix. So about incidence matrix I am not discussing in this lecture, okay. So you can calculate the number of trees, number of possible trees from this formula, okay, determinant of A into A transpose, okay, where A is an incidence matrix. So there could be many trees from a particular graph, and in all the trees you can observe the total number of nodes will be equal to the number of nodes in the graph, but the number of branches will be equal to or less than the number of branches in a graph. So you can see here in this, let's talk about this tree. In this tree this is branch number 1 and 3 will be called as twig, but the left out branches, that is branch number 2, branch number 4 and branch number 5, these will be, I can represent these branches with the dotted line, right, okay, and these are called as the link or cord. So for this particular tree, I am talking about this tree, for this particular tree twigs are branch number 1 and 3, okay, and links are branch number 4, 5 and 2, that is 2, 4 and 5 will be the link for this particular tree, okay. Similarly you can see for this particular tree, here 2 and 3 are the twigs and rest of the branches, that is branch number 1, 4 and 5 are called as the link. And please remember that these twigs are always be represented by the bold lines as I have drawn here, and these links will be drawn will be shown by the dotted lines as shown here. So in this case I am once again showing the links in for this particular tree. 2 and 3 here are the twigs, right, and branch number 1, okay, and branch number 4 and branch number 5, will be called as the link and will be represented by dotted lines. Okay. Now these are the properties of the trees. As I have already discussed, that a tree will consist of all the nodes of any given network, right? A tree has the number of branches which is either less than one of the number of nodes of the given network. If there are n nodes, then the number of branches of tree will be n minus 1, right? And those branches are called as the twig, right? A tree must not contain any closed loop, and there could be many possible many different possible trees for a particular network, right? And the sum of branches, right, in a tree and the number of branches of its crow tree will be equal to the number of branches of a network. Let's verify this last point also. You can see this tree I have taken, right? So here branch number 1 and 3 are the twigs, and the branch number 2, 4 and 5 ये लिखा है मैंने, here are the links. So you can see total 1, 2, 3, 4, 5, all the 5 branches are including, and tree and co-tree will, sum of tree and co-tree will form the graph. Co-tree is a co-tree is that subgraph which is not included in the tree. ट्री में ये दो ब्रांचेस इंक्लूड हुई, ब्रांच नंबर 1 और 3, ठीक है. जो ब्रांचेस, the branches which are not the part of the tree are called as the link and also called as the co-tree, ठीक है. यानी फॉर दिस ग्राफ आप देखिए ब्रांच नंबर 1 और 3 ये ट्री बना रही हैं, these are called as the twig, and branch number 2, 4 and 5 these are called as the link, and ये क्या बोली जाएंगी, co-tree. और इन सबको जब हम देख रहे हैं तो यू कैन सी ये और ये इट इज सेम एज द ग्राफ. तो जो सम होगा ब्रांचेस का ऑफ ट्री एंड को-ट्री की ब्रांचेस यानी ट्विग्स एंड लिंक्स का जो सम होगा विल बी इक्वल टू द नंबर ऑफ ब्रांचेस इन अ ट्री, एंड टुगेदर दे फॉर्म द ट्री. So this point is also verified. Now I have already discussed about the co-tree. What is co-tree? Co-tree is a subgraph which is formed with the branches that are removed while drawing a tree. किसी भी ग्राफ से जब हम ट्री बनाते हैं, then जो branches which we are removing, which we are not considering, are will form the co-tree. And you can say also, you can also say कि co-tree is a complement of tree, right? And there will be corresponding co-tree and its branches which are called as links या फिर chords. ठीक है. For this graph, you can see for this graph, let's say I have selected this tree. Okay, you can see 1, 2, 3 and 4. There are 4 nodes. This tree is containing all the 4 nodes. Node number 1, 2, 3 and 4, right? And there is no closed loop, right? And the number of branches that is of a tree, that is twig, is 1 less than the number of nodes. Total 4 nodes है और 3 branches है, यानी 3 twigs हुई. Twigs का फॉर्मूला क्या बताया था अभी, n-1, ठीक है. तो there are total 4 nodes and there are total 3 twigs, ठीक है. And now ये क्या बन गया हमारा, this is a tree. Now the left out branches, that is branch C, branch number B, okay, and branch C and branch A are forming a co-tree here. Okay, तो मैं इसको separately भी I can show here. And one point to be noted here is that it is not necessary for a co-tree that it will contain all the nodes of a tree, of a graph. जैसे कि ट्री के लिए कंपल्शन है कि इट मस्ट इंक्लूड ऑल द नोड्स ऑफ अ ग्राफ, ऐसा कोई कंपल्शन नहीं है फॉर द को-ट्री. ओके, ट्री में सारी नोड्स इंक्लूड हुई हैं ऑफ द ग्राफ, बट यू कैन सी हियर दिस इज को-ट्री एंड दिस इज सिंपली अ ट्री. लेट मी once remove these branches so that you can differentiate co-tree and tree. See, this is the tree for this graph. It is having all the nodes 1, 2, 3, 4, right? और कोई closed loop नहीं है, ठीक है. तो ये जो इसकी ब्रांचेस हैं, these are called as the twigs and this is the coterie, वो पार्ट जो ऑफ द ग्राफ जो कि हमारे ट्री में इंक्लूड नहीं हुआ, राइट, द लेफ्ट आउट पार्ट ऑफ द ग्राफ which is not included in the tree is called as the coterie. And you can see total कितनी nodes थी, there are total 4 nodes, right, and in this coterie there are only 3 nodes are included. So it's not a compulsion कि all the nodes will be included in a coterie, but for a tree it's a compulsion, it's one of the property, right. And you can also see this is forming a closed loop. So for coterie there is no compulsion for any closed loop for any number of nodes. Coterie में only left out branches will be the coterie, okay, and together they form a tree, together they form a graph, okay. अगर I'll join this tree with this coterie तो मुझे क्या मिलेगा, this graph, I'll get this graph. So this is the graph and this will be obtained from any particular electric network, right, and this, from this graph we can draw the tree, we can also draw the coterie. So let me write down the names of the branches, that is D, E, F here, and this is B, and this is C, and this is A, right. So you can see that D, E, F here are the twigs, D, E and F are called as the twigs here, and branch A, B and C are called the links. I hope it is clear to you all. And you can see here the number of links will be equal to B minus N minus 1. Total number of branches जो कि हमारे पास ग्राफ में थी, right, and N minus 1 क्या था हमारा formula for the twig. तो total number of the graph की branches minus the number of twigs will form the tree. You can see here total number of branches इसमें कितनी है, A, B, C, D, E, F, total 6 branches हैं, okay, and 3 branches हमारी किसकी हो गई, tree की हो गई. So left out branches 1, 2, 3 branches बची coterie की. So coterie किससे represent कर रहे हैं, by the link. So formula for the twig will be N minus 1, right. कितनी nodes थी, there are 4 nodes, और twig यहाँ पे देख सकते हैं आप 1, 2, 3 nodes हैं, twigs हैं. So formula for the twig will be N minus 1, and formula for the link will be total number of branches of the graph, that is 6, okay, and 6 minus number of twigs कितनी थी, 3, तो कितनी आई आपकी links, 3 आई. So you can write the formula for the link is B minus N minus 1, okay. So here a B minus N minus 1, you can simplify it and you can write it B minus N plus 1, where L is the number of links, B is the number of branches present in any graph, and N is the number of nodes present in the given graph. Now let's start with the cutset matrix. What is a cutset matrix? It is also called as the fundamental loop matrix, right, and basically this cutset matrix is used to find out the number the current in any branch, right. So in case of loop matrix, or you can say cutset matrix, only one link will be considered at a time, and there could be any number of twigs. See, it contains only one link and one or more twigs, right. Any number of twigs can be there in any particular cutset, but there will be only one link, right. So the number of cutset matrix, number of cutset rows actually will be equal to the number of links, okay, and it is represented by the letter capital B, okay. So I have told you it is used to find out the current in any branch. So we can also use this matrix to find out the relationship between the branch current and the link current, okay. So if there are n nodes present in any graph, right, and there are B branches in that graph, so the number of links will be present in a coterie, right. So which is equal to the B minus N plus 1. So there will be a cutset matrix of the order of B minus N plus 1 into B. See, the elements only, there will be entry of 3 elements in any Tysset matrix, that is +1, -1 and 0. ठीक है. So this is the procedure how to draw any particular matrix, Tysset matrix. ठीक है. सबसे पहले we have to select any tree, then by taking one link at a time and any number of twigs at a time will find the values of the elements in the branch, and उसके लिए भी we have to follow these rules. If the value of the if the direction of that branch is same as the direction of the link, right, then it will be taken as +1, and if the direction is opposite then will be taken as -1. Selected same +1, then it will be taken as -1, same के लिए +1, and if there is no connection of the branch with that particular loop, right, so we'll write 0. Okay, and we'll repeat all these steps for different links. So I have taken this example to write down the Tysset matrix. So the graph is given to us and I have to write the Tysset matrix for this graph. First of all, I'll select a tree from this graph. Let's see, you can select any tree. I have drawn many trees from a particular graph. You can select any tree. Okay, I'll select a tree. Okay, and if the direction of branches and names of the branches is not given to you, then you can assume yourself. So this is node number 1, node number 2 and node number 3 and node number 4, right? So this is the tree that I have selected. Now here you can see in this tree branch 1, branch 4 and branch 5 are the twigs here, right? I'll write down the number of twigs. Twigs here are 1, 4 and 5. Now link will be, in this case, 2, 3 and 6 will be the link. 2, 3 and 6 will be the link. Okay, I will represent it with the dotted line. Now as I have told you, the number of rows in a Tysset matrix will be equal to the number of links. So there are total 3 links, right? 2, 3 and 6. So the number of rows of a Tysset matrix will be equal to 3. Okay, and now how to draw? We'll take one link at a time and any number of twigs can be there to form a single closed loop. Okay, for link number 2, I can consider branch 4, 1 and 2. Sorry. So in this case I have taken 2 twigs 1 and 4 along with the link 2. ठीक है. So there are total 3 Tysset matrix के लिए loops बनेंगे. एक टाइम पे एक लिंक लेना है, कितने भी twigs ले सकते हैं और उसके साथ आप क्या करेंगे, एक क्लोज लूप फॉर्म करना है. मैंने बताया कि Tysset matrix is used to find the current. ठीक है, तो will एक current closed loop में current will flow, okay, and the direction of that current will be the direct same as that of the link. तो इस लिंक में, इस लूप में ये क्लोज लूप बन रहा है, तो I'll represent it by I2 क्योंकि name of this link is 2, so I'll represent it by I2 and the direction of this link, this current will be same as that of link. So there are total 3 link है, तो 3 क्लोज लूप बनेंगे. We'll consider one link at a time and कितने भी twigs हो सकते हैं. आप कुछ भी लूप बनाइए बट आप twig लिंक एक ही रखेंगे, twigs कितने भी रख सकते हैं. ओके, एक 2 के लिए हो गया, ये एक 3 के लिए ले लेते हैं. दिस इज द लिंक नंबर 3 एंड इसके साथ मैं ब्रांच नंबर 4 कंसिडर करूंगी एंड ब्रांच नंबर 5. ओके, दिस इज ब्रांच नंबर 4, 5 एंड दिस इज link number 3, right? So I'll give the name to this current is I3 and the direction of this current is same as that of this link. ठीक है, and last one is 6th link is left, right? तो 6th वाले के साथ we can consider branch 1, 5 एंड लिंक नंबर 6, ठीक है। सो 1, 5 एंड 6। नाउ अब मैं इसमें कौन सा नाम दूंगी करंट का, I6 दूंगी, एंड डायरेक्शन ऑफ करंट विल बी सेम एज दैट ऑफ 6th ब्रांच, दैट इज 6th लिंक के जैसी जो भी डायरेक्शन है वो हमने कंसिडर करी। नाउ अब मैट्रिक्स कैसे बनानी है, एज आई हैव सेड इट इज रिप्रेजेंटेड बाय कैपिटल B, ओके ओके। मैं आई रब दिस, मैं यहां पे लिख देती हूँ लिंक 2, 3 and 6, okay. So in this side, I write down the names of the links, ठीक है। There are 3 links ना, तो I'll write down the I2, I3 and I6, I2, I3 and I6, जो भी करंट हमने फ्लो कराया है इन तीनों में, I'll write down these names, and जितनी भी टोटल ब्रांचेस थी, there are total 6 branches, तो number of branches will be written here 1, 2, 3, 4, 5 and this is 6, ठीक है। This is branch node number 4 ना, ठीक है। Now see this I2, in this case I2 वाला, consider this one, this current I2 is flowing in this, so यहाँ पे we are taking branch number 1, 2 and 4, right, मतलब ब्रांच नंबर 3, 5 एंड 6 इस वाले लूप में कंसिडर नहीं हो रही है, राइट। सो ब्रांचेज विच आर नॉट कनेक्टेड इन एनी लूप विल बी गिवन एज 0, तो ब्रांच नंबर 3, 5 एंड 6 विल बी मार्क्ड एज 0 here, ठीक है। एंड द ब्रांचेज विच आर हैविंग द सेम डायरेक्शन एज दैट ऑफ अ करंट और यू कैन से लिंक विल बी गिवन एज +1, एंड विच आर हैविंग opposite direction to that of current or you can say link will be given as -1। तो यहाँ पर only 1, 2 and 4 ही रह गया हमारे पास, 1, 2 and 4 लेफ्ट है। तो आप देखिए 1 की डायरेक्शन स्टार्ट करते हैं 2 से, 2 की डायरेक्शन तो सेम ही होगी ऑलवेज, है ना, लिंक करंट की डायरेक्शन विद दिस लिंक, तो 2 में तो +1 आ जाएगा, आई राइट +1 विद दिस 2, ठीक है। एंड 4 की डायरेक्शन देखिए, सेम डायरेक्शन में करंट फ्लो कर रहा है, 4 की डायरेक्शन डाउनवर्ड्स है और करंट की डायरेक्शन भी यहाँ से डाउनवर्ड आ रही है, तो अगेन आई विल गिव हियर +1, सेम डायरेक्शन के लिए +1, अपोजिट डायरेक्शन के लिए -1, और अगर वो ब्रांच इंक्लूड ही नहीं हो रही है उस पर्टिकुलर लूप में तो विल गिव 0। एंड डायरेक्शन नंबर 1 के लिए देखिए सेम डायरेक्शन है ब्रांच नंबर 1 में, तो अगेन +1 और 1 एक ही बात है ना। नाउ सी दिस वन फॉर I3, यहाँ पे कौन सी ब्रांचेस इंक्लूड हो रही हैं, 3, 4 एंड 5, दैट मीन्स फॉर ब्रांच 1, 2 एंड 6 आई विल राइट 0, 1, 2 एंड 6, ओके, आई विल राइट 0। नाउ लेफ्ट ब्रांचेस 3, 4 एंड 5, 3 की डायरेक्शन तो ऑलवेज सेम डायरेक्शन होगी करंट की, वही हमने कंसिडर करी है, तो क्या हो जाएगी +1। यू कैन सी हियर 4 की डायरेक्शन भी सेम आ रही है, डाउनवर्ड जा रही है, तो 3 एंड 4 में +1 +1 +1, एंड यू कैन सी 5 की डायरेक्शन क्या हो जाएगी, अपोजिट आ रही है, 5 एंड I3 की डायरेक्शन अपोजिट हो रही है, तो 5 में क्या लिखेंगे हम, -1, ठीक है। एंड सिमिलरली ये वाला केस देख लेते हैं 6th लूप के लिए, तो ये कौन सी होगी यहाँ पे, दिस इज ब्रांच नंबर 1, तो 1, 5 एंड 6 आर इंक्लूडेड हियर, राइट, तो 2, 4 एंड 3 में, 2, 3 एंड 4 में क्या आ जाएगा 0, 2, 3 एंड 4 में हमने क्या लिख दिया 0। नाउ 1 में क्या डायरेक्शन, आप यहां से देखिए 1 की डायरेक्शन इज अपोजिट टू दिस ऑफ दिस करंट, है ना, तो 1 पे क्या लिखेंगे -1, और 5 की डायरेक्शन भी अपोजिट आ रही है, तो 5 पे भी -1 लिख देंगे, एंड 6 की डायरेक्शन देखिए सेम है, 6 की तो डायरेक्शन सेम ही होगी, तो 6 के लिए हो गया +1, ठीक है। सो दिस इज द टाइसेट मैट्रिक्स, ठीक है, फॉर दिस। अब ये टाइसेट मैट्रिक्स एक बार और मैं क्लियरली इधर बना देती हूँ। हम क्या कर रहे हैं, I2, I3 और I6 हमने लिया था, वही मैं दोबारा लिख रही हूँ यहाँ पर, वंस अगेन आई एम राइटिंग हियर I2, 2, 3 एंड 6, ओके और हमने यहाँ ब्रांचेस के सारे नेम देने हैं 1 2 3 4 5 एंड 6, ठीक है। तो I2 के केस में क्या है 1 1 0 1 0 0, ठीक है, 1 1 0 1 0 0। I3 के केस में 0 0 1 1 -1 0 0 0 1 1 -1 0 एंड I6 में क्या है -1 0 0 -1 +1 -1 0 0 -1 +1। अब इसमें दो चीजें ध्यान देनी है आपको। पहला तो ये कि जो दिस करंट शुड बी रिटन इन असेंडिंग ऑर्डर, ठीक है। वी कैन ऑल्सो वेरीफाई दिस टाइसेट मैट्रिक्स, ओके, कि हमने सही लिखी है कि नहीं। तो उसके लिए आपको दिस करंट शुड ऑलवेज बी रिटन इन असेंडिंग मैट्रिक्स 2 3 6, ठीक है। इनका अगर ऑर्डर ऊपर नीचे हो जाएगा तो आप वेरीफाई नहीं कर पाएंगे अच्छे से। सो यहाँ पे आप देखिए कि हमारा 2 3 और 6 है, तो हम लिंक नंबर 2 था यानी कि, और 3 था और 6 था। सो टुगेदर दिस 2 3 6 को हम एक साथ लिख सकते हैं, 2 3 एंड 6 को हम एक साथ लिख सकते हैं, एंड 1 4 5 को अलग लिख लीजिए। तो आप चेक करेंगे जब हम 2 3 6 को एक साथ लिख रहे हैं तो ये आ रहा है 1 0 0 0 1 0 एंड 6 में क्या आ रहा है 0 0 1, ठीक है। और 1 4 5 में हम लिख लेते हैं जल्दी से 1 0 -1 1 1 0 एंड 5 में 0 -1 -1। यही तो हमारी मैट्रिक्स बनी थी। सो यू कैन सी कि ये जो मैट्रिक्स बनेगी 2 3 6 से, है ना, जो हमारे लिंक्स की हमने क्या किया, मैंने लिंक्स को पहले लिख दिया, फिर उसके बाद बची हुई ब्रांचेस को लिख दिया। तो ये मैट्रिक्स आपको समझ में आ रहा है, इट इज एन आइडेंटिटी मैट्रिक्स। हमेशा लिंक से आप चेक करेंगे तो आइडेंटिटी मैट्रिक्स बनेगी। 1 0 0 0 1 0 3 by 3 की बन रही है, राइट। और इस ऑर्डर क्या होगा इस मैट्रिक्स का, हमेशा जो भी टाइसेट मैट्रिक्स बनेगी वो होगा 3, ये जो भी आपका था b - n - 1 इंटू b नंबर ऑफ ब्रांचेस। तो आप देखिए इसमें b - n - 1 तो 3 आया था हमारा, तो 3 इंटू 6 की ये मैट्रिक्स बनी। उसमें भी वेरीफाई करने के लिए कि आपने सही बनाई है कि नहीं, यू कैन राइट डाउन द नंबर ऑफ लिंक्स टुगेदर, ठीक है, एंड इट शुड बी एन आइडेंटिटी मैट्रिक्स। अगर ये आइडेंटिटी मैट्रिक्स बन रही है तो टाइसेट मैट्रिक्स इज वेरीफाइड, इट इज ओके, करेक्ट। नाउ अनदर एग्जाम्पल, I have to draw the Tysett matrix for this graph. So for this graph I'll select this tree, okay, branch number 4 and branch number 3. Now here हमारे पास 2 twigs हो गए और 2 ही links हो जाएंगे। तो ये नोड नंबर 1 यूज किया मैंने, ये नोड नंबर 2 और 3, सारी नोड्स इंक्लूड करी। 4 और 3 को मैंने एज ट्विग लिया, तो नोड नंबर, ये ब्रांच नंबर 2 हमारी यहाँ पर हो गई लिंक, और ब्रांच नंबर 1 भी हमारी यहाँ पर क्या हो गई, लिंक। नाउ अब कितने मेरे टाइसेट के रोज बनेंगे, 2। एक बार 1 को कंसिडर करके यहाँ पे ट्विग्स कौन कौन से हैं हमारे पास, 3 and 4, एंड लिंक्स कौन कौन से हैं, 1 and 2। So there will be 2 rows for the Tysett matrix. Now कौन कौन से ग्राफ बन जाएंगे, एक बार 1 4 3 कंसिडर कर सकते हैं, एक बार 2 3 4 ले लें हम। 3 4 के साथ मैंने, देखिए अब मैंने कितनी भी ब्रांचेस के साथ क्लोज लूप बनाए कोई प्रॉब्लम नहीं है, एक ही लिंक कंसिडर किया है एक टाइम पे, 2 ट्विग्स कंसिडर हो रही हैं, राइट। ऑल द नोड्स कितनी भी हो सकती हैं, नोड से कोई प्रॉब्लम नहीं है, ठीक है। और दूसरा ग्राफ क्या बनेगा, ये 1 को कंसिडर करेंगे, 4 3, ठीक है, 4 3 एंड दिस इज 1, ठीक है। सो इसमें डायरेक्शन ऑफ करंट, इसको किससे रिप्रेजेंट करेंगे, I2 से, और डायरेक्शन ऑफ करंट विल बी सेम एज द डायरेक्शन इन द सेकेंड ब्रांच, एंड ये हो गया हमारा I1 से रिप्रेजेंट करेंगे, और डायरेक्शन सेम हो गई फर्स्ट ब्रांच के जैसी। तो यहाँ पर B इज इक्वल्स टू, नो मैट्रिक्स B विल बी इक्वल टू, यहाँ पे हम लिखेंगे I1 I2, और कितनी ब्रांचेस हैं टोटल, 4, तो 1 2 3 एंड 4, ठीक है। सो इन केस ऑफ I1 यू कैन सी 1 3 4 इंक्लूड है, तो 2 पे तो 0 लिख दिया क्योंकि ब्रांच नंबर 2 इज नॉट इंक्लूडेड हियर, राइट, एंड 1 इज सेम डायरेक्शन में करंट की, तो +1, 4 अपोजिट डायरेक्शन में जा रही है तो -1, एंड 3 की डायरेक्शन सेम है एज I1, तो हम क्या लिखेंगे +1। एंड इस केस में आप देखिए 2 3 4 इंक्लूड हो रही है, तो 1 पे तो 0 लिख दिया हमने, ठीक है। एंड 2 का सेम डायरेक्शन है करंट के जैसे, I2 का +1 एंड 3 का अपोजिट डायरेक्शन शो हो रहा है यहाँ पे -1, और 4 का भी सेम डायरेक्शन रहेगा तो +1। अब यहाँ पर हमारा 1 एंड 2 लिंक्स थे, तो आप चेक कर सकते हैं 1 एंड 2 हमने यहाँ पे ऑलरेडी सेपरेटेड ही है, तो 1 एंड 2 क्या बना रहा है, ये आइडेंटिटी मैट्रिक्स बन रहा है, ठीक है। आइडेंटिटी मैट्रिक्स बन रही है, तो दैट मीन्स दिस इज करेक्ट, this dissect matrix is correct. So if you have any queries you can ask. If anybody is having any query, then you may ask. I think time is over, so I'll discuss this cutset matrix in the next lecture. So that's all for today's lecture.